first, the very basic method of differentiating, which is your method of first principles. Okay. Now, if you're asked to use first principles to solve a question, you cannot do otherwise. Okay, you have to differentiate using first principles because that is the instruction. Okay. Now, let's start with the very basic one. Let's say, for instance, y is equal to x, and I want to find the derivative of y. That is to say, I want to look for the y over dx, or I want to look for y prime. Okay, so the y over dx and y prime actually still implies differentiate y. Okay, now the first thing I will do is to increase both sides by data x and data y. I'm going to increase the left hand side, okay, by data y. Then also I'll increase the right hand side by data x. Okay, so in the first step I would say as y increases by change in y, x increases by change in x. Okay, so it means that I'm going to do this. On the left hand side, I'll say y plus change in y is equal to x plus change in x. Okay, now at this point, let's make change in y subject. So I can say change in y is equal to x plus change in x minus y. Remember that y is equal to x. Okay, so it means that these two guys are exactly the same and they can cancel out. So we are left with change in y is equal to change in x. Now I'm going to divide both sides. That's the next thing. I'll divide both sides. I'll divide both sides by change in x. When I do this, I'm going to have change in y divided by change in x is equal to change in x divided by change in x. Okay. So we now have that change in y over change in x is equal to 1. Now at this point we take limits, okay? We take limits as change in y over change in x tends to the y over dx, change in x tends to 0. This is the limit to take at the very end, okay? So I can say finally, I can say that the y over dx is equal to 1. And that's the very simple question. Okay, let's go to a more tougher question. This time around, the question says that we should we should find the derivative of y equal to x squared. Okay, find the derivative of y being equal to x squared. Now, as usual, the first thing we're going to do here is we're going to see how we can increase both sides. Okay, we increase y by changing y, what we did before. So we increase y by changing y, we have y plus changing y. We're going to increase x by changing x again. So we have x plus change in x, but there's a squared. Okay. So the next thing I'll do here is this. It becomes change in y plus change in y is equal to, if I expand this guy here, I'm going to be having x squared plus 2x change in x plus change in x squared. Okay. You can do the expansions manually or you can use binomial expansion. Okay. Now, I can say therefore that change in y, if I take y to the other side, I'll be having x squared plus 2x change in x plus change in x squared then minus y. Okay. Now change in x squared, okay, y and x squared are the same, so I can actually say that x squared will cancel out y. So what I have here is data y is equal to 2x data x plus data x squared. At this point, I'm going to divide both sides. I'm going to divide throughout the equation by changing x, okay? So I'll divide throughout the equation by changing x. If I do that, I'm going to be having change in y over change in x is equal to 2x plus change in x. Now at this point, I can now take my limit. I can take the limit as change in y over change in x tends to the y over the x. Okay, you can say that change in x tends to 0. So it means that I can now finally say the y over dx is equal to 2x. Okay, because change in x is now 0. So this is it. Now we're going to make the question a little bit more difficult. Here the question says that y is equal to 4x cubed minus x. Okay, y is equal to 4x cubed minus x. Okay, so we'll do the same thing as usual. We're going to increase y by changing y. So we'll have y plus changing y to increase the x by changing x. So this gives us 4 into x plus change in x, but there's a cube, don't forget. Now minus x plus change in x. So at this point, we have to do the expansion for x plus that are x all cube. Okay, you can use minimal expansion I told you to expand it, or you can do it manually. You could say this here is something as saying x plus change in x multiplied by x plus change in x multiplied by x plus change in x. Okay, so that's what it means, right? Now at that point, you can actually do the expansion manually, or you could expand using binomial theorem. That would give us y plus change in y is equal to 4 open bracket. This is x cubed plus 3x squared change in x plus 3x change in x squared plus change in x cubed. Okay, minus x plus change in x. So we can expand here. So we have y plus change in y is equal to, if I open bracket, I'll be having 4x cubed plus 12x squared change in x plus 12x change in x squared plus 4 change in x cubed. Then if I open the bracket here, I'm going to be having minus x minus change in x. Okay, so I can actually do this. Okay, I could bring this and this together. So I have that, and at the same time, I want to carry y to the other side. So I have that change in y is equal to 4x cubed minus x plus 12x squared change in x here plus 12x change in x squared, then plus 4 change in x cubed. Then if I move y to this side, I'm having minus y. Okay. Now don't forget that everything here, remember, but everything there, 4x cubed minus x is already y. So it means that this guy, everything here could actually cancel out everything here. That's what it means. That's what it implies. Okay. So at this point, what we're gonna do, remember that remember this guy here, we're still left with minus change in x. So remember it's here, so we are not going to omit. Okay. So the next thing we'll do here is simple. We'll divide through by changing x. Okay. Let's divide through by changing x. This becomes change in y over change in x is equal to 12x squared change in x over change in x plus 12x change in x squared over change in x plus 4 change in x cubed over change in x, then minus change in x over change in x. Okay, so at that point in time, this guy cancels out this guy. So we have that change in y over change in x is equal to 12x squared. Okay, then this guy cancels out this guy. We'll be having plus 12x into change in x Then if this cancels this one, then we'll be left with plus 4 change in x squared. Then this cancels out this, we'll be having minus 1. At this point, you can take limit, okay? You can take limit that as change in y over change in x tends to the y over the x. Also, change in x tends to 0, okay? So this means that we can now say finally that the y over dx is equal to, this gives us 12x squared, okay? Then this change in x is already 0, so this guy goes out. This guy goes out because this is something as saying plus 12x into 0 plus 4 into 0 squared. So well, remember we're having minus 1 left, so we have dy over dx is equal to 12x squared minus 1 as our final answer. Let's say what we have in this question. Let's say y, we asked to differentiate y is equal to square root of x using first principles, okay? Using first principles, okay? Now we'll do the same thing here. We'll do the same thing as y increased by changing y. So we have y plus changing y. X also increases by changing x. So we have square root of x plus changing x, okay? So we're going to have changing y is now equal to square root of x plus changing x minus y. Remember that y is square root of x, so we now have that change in y is equal to square root of x plus change in x minus square root of x. Now, when we get to this point, we're going to apply a method in maths called rationalization. Now, what we have here is a sort. Okay, so what we're going to do, we're going to see how we can rationalize this sort. And remember that when we rationalize a sort, okay, when we rationalize a sort, rationalizing, we're going to multiply the sort, the top and bottom of the sort, by the conjugate of the sort. Okay. So what we have, the conjugate of this sort is to change the sign here to positive. Okay. So I'm going to rationalize. When I rationalize, I'll be having that y is equal to square root of x plus change in x minus square root of x. I'll multiply this guy by square root of x plus change in x. Let's take it closer here. So I have that change in y is equal to square root of x plus change in x minus square root of x multiplied by square root of x plus change in x plus change in x. Okay, now divided by square root of x plus change in x plus change in x. So this is what it means to rationalize. So we're going to rationalize this guy here. Now remember that what we have here is a difference of two squares. Remember that when we have p minus q multiplied by p plus q, this is going to eventually give us p squared minus q squared. This is an expression called the difference of two squares. Okay, so it means at the numerator there at the top we can do this. This becomes square root of x plus change in x squared minus square root of x squared, okay, divided by square root of x plus change in x plus change in x. Now, since what we have here is sod, this guy can actually go out with this, and this can go out with this, okay. If I square is sod, the square root can cancel out, okay. So what I have left is easy. I have left that change in y is equal to x plus change in x minus x divided by square root of x plus change in x plus square root of x. Now, x minus x can go out. So we have that change in y is equal to x change in x over square root of x plus change in x plus square root of x. Okay. Now at this point, you can now divide both sides by changing x. Okay. So we're going to have, or I can say I can multiply both sides by 1 over changing x. Okay. So if I multiply here by one over changing x, I'm going to multiply here by 1 over changing x. Okay. So this gives us changing y over changing x is equal to, these two guys can go out here. 1 divided by square root of x plus changing x plus square root of x. At this point, we can take limits. Okay. We can take limit as, we can take limit here that as changing y over changing x tends to the y over dx. Then change in x tends to 0. And take limit here. Okay. So at this point, you can say the y over dx now is equal to 1 divided by, okay, here I see change in x, I'll put 0. So it becomes square root of x, okay, plus square root of x. So what we have becomes the y over dx is equal to 1 divided by 2 square root of x. Okay, this is it. So this is our answer. Okay. All right, let's take questions that involve trigonometric functions. Okay, questions that actually involve trigonometric functions like the sine function, the cos function, and sine function, cos function, sec function, cot function. Okay, let's start with sine. Okay, if y is equal to sine x, now let's find the derivative of y using first principles. Okay, we'll do the same thing here as y increase by changing y. As y increases by changing y, so we have y plus changing y. X will also increase by changing x. So we're going to be having sine into x plus change in x. Alright, now so we're going to make change in y subject. So we have that change in y is equal to sine into x plus change in x minus y. Of course, you know the same thing as saying change in y is equal to sine into x plus change in x minus sine x. Okay, now I'm going to show you from this particular place, I'll show you two methods to go with. Okay, we could decide to find the trigonometric identity. Remember that when I have sine into a plus b, remember that the result of sine into a plus b is equal to sine a cos b plus cos a sine b. Remember, so let's do the same thing here. So I can see that change in y is equal to, if I applied what I just did here down here, I'll have that this gives us sine x cos change in x plus cos x sine change in x. Okay, remember that we have minus sine x here. Okay, minus sine x here. Now, there comes a time where change in x becomes very small. If change in x is infinitesimally small, if change in x is infinitesimally small, then don't forget that we could say sine change in x will give us change in x, and change in x gives us change in x. However, cos change in x can give us 1. Okay, so when change in x becomes infinitesimally very small, that is when change in x is very very small, sine of change in x tends to change in x, tan of change in x tends to change in x, but cos of change in x tends to 1. Okay, when change in x is very very small. So if I should substitute what I have just said here, I can say that change in y is equal to, where I see cos change in x, I'll put 1. So I have sine x into 1. Okay, where I see cos sine change in x, I'll put change in x. So it becomes plus cos x into change in x. We're left with minus sin x, okay? At this point, you know these two guys can actually go out. So what we have change in y is equal to change in x cos x, okay? Now divide both side by change in x, divide here by change in x, also divided by change in x. So these two guys can go out. So I have that change in y over change in x is equal to cos x. We're not done yet. Remember that finally you can see that as change in y over change in x tends to the y over the x. Okay, change in x tends to 0. So I can say that the y over the x is finally cos x.